So in this video short, I'm going to talk about molarity. So this usually throws students for a loop, so pay attention, take notes, and rewatch if necessary. Okay, so molarity, so not everything we look at in life is a pure substance. So we can't just always be calculating off the periodic table formula masses and call it a day, right? We like to dissolve salt in water. For saline solutions, maybe spray up your nose to try to rid ourselves of mucus. We dissolve sugar, so we dissolve solids in liquids, right? Sugar and coffee. And there's a way to express that, and that's not via formula mass or calculating molar masses of things. No. What we look at there is we look at the molarity. So molarity is also it's a unit of concentration, and the units break down into the moles of the solute over the liters of the solution. So remember, a solute is something you dissolve in. So if I have sugar dissolving in my coffee, the solute is the sugar and the coffee is the aqueous coffee is the solution, right? And if I'm making my saline solution, I take some salt and pour it in with water. The moles of the solute is the sodium chloride and the solution is water. Okay, so these are the units though, it's moles per liter. So molarity is gonna provide us with a connection between volume of something and how many moles are in that volume. So just like formula mass links grams to moles, molarity links volume to moles of a homogeneous mixture. So let's look at an example. If 355 milliliter soft drink sample contains 0.133 moles of sucrose, what is the molar concentration of sucrose in the beverage? So again, the formula is molarity equals moles per liter. So how many moles do I have? Well, lucky you, they already just gave you the number of moles. So 0.133 moles is my numerator. And how many liters of the solution do I have? It's a 355 milliliter soft drink, and to convert milliliters to liters, you just have to move the decimal place 3 times. 1, 2, 3, 3 to the left. Almost you need to have that ingrained in your memory too by the end of this class, if not by the end of this chapter. Okay, so 0.133 divided by 0.355 liters would give me 0.375 molar. So this capital M is molar. Okay, so it's not 0.375 moles. No. It's 0.375 molar. I think, okay, so that's that example. There's lots of examples in the homework, so you can work on those. And sometimes instead of starting with moles, you might have to start with grams. So if a soft drink contained 10 grams of sucrose, and how would you go from grams to moles? Remember, the link from grams to moles is molar mass. So you would have to calculate the molar mass and then convert grams to moles first, and then you've got your moles. And then the volume of the solution always must be in liters. I guess that might be the big thing. So it's always in liters. Okay, so dilution. All right, so when we usually, in a lot of questions, so when you dilute something, this is not something new. You've probably been diluting things your whole life, but now we're just putting some math behind it. So normally, especially in chemistry lab, we'll have a stock solution, which is a higher concentration of something, and you usually use that to dilute down and make the concentrations of solutions that you want. So the stock solutions tend to be more concentrated. So maybe out of these two, right, in the chemistry equipment room, there's a stock solution of this copper nitrate, and it's about this dark because it's more concentrated. And then to make my working solution, I want it at this, certain concentration. So I take a little bit of my stock solution and dilute it with some water, and voila. But this whole section is going to be talking about how do we calculate the concentrations. So there's a formula for that. I'm going to skip up here. And the formula for dilutions is C1V1 equals C2V2. Okay, C stands for concentration. So the concentration times the volume equals the concentration times the volume. Okay, notice my subscripts 1 and subscripts 2s. Okay, subscript 1 is maybe the before, and subscript 2 is the after. It honestly doesn't matter what you call 1 and 2. You just have to keep the volume with the right concentration every time. Okay, so let's look at an example of a dilution problem. So if 0.850 liters of a 5 molar solution of copper nitrate is diluted to a volume of 1.8 liters by adding water, what's the molarity of the diluted solution? So here's our C1V1 equals C2V2. So again, we just have to keep together concentrations and volume. So my concentration is 5 molar. Okay, and then what volume of 5 molar am I using? Am I using 0.85 or am I using 1.8? I'm using 0.85. Okay, so we're going to keep those two together. So we're going to call that C1, concentration one's 5, and V1 is 0.85. Okay, equals, so then my dilution side. So I don't know what the concentration is. So C2 is the X in my algebraic equation. I don't know what the concentration is, but I do know that I diluted it all the way up to 1.8 liters. So that's my V2. So if I, so you have a known here, a known here, an unknown here, and a known here. So if we just divide by V2 on this side, right, we can isolate our unknown and plug in all of our numbers that we know. So the concentration of 2, which was our diluted solution, is equal to 5 molar times 0.850 liters divided by 1.8 liters. Look how liters cancel here, and you're left with units of molar. So the new concentration is 2.35 molar. And that sums up a dilution problem. So there's a lot more to work on in the homework. So, but that just gives you a good jumping point.